Hello, and welcome to the More You Know YouTube channel. Today we will be discussing Newton's laws of motion. Newton had three laws of motion. The first is that an object in motion stays in motion, unless a force acts on it. The second is that an object's force is equal to its mass times its acceleration. And the third law is that when two objects interact, they apply forces to each other of equal magnitude in opposite directions. While it may be overwhelming now, you should have it mastered by the end of this video and know how to solve for Newton's second law. Newton's first law is pretty self-explanatory. An object in motion will stay in motion unless another force acts on it. Newton's first law of motion is in action in this scene. The ball player is throwing the ball, and it will continue to move until acted upon by another force. This is seen when the ball falls due to the gravitational forces or outside interference. Newton's second law of motion is that the force of an object is equal to its mass times its acceleration. This formula is represented in blue on the lower left side of the chalkboard. It is important to remember that force is always represented in newtons. The conversion formula for kilograms to newtons is on the lower right side of the board, in blue. Now it's time to see how this is done. One big question is how much force do we naturally feel from gravity here on Earth? On Earth, we feel our acceleration while falling at a rate of 9.8 meters per second. This would be our acceleration when we calculate mass with a known weight. This is represented in blue in the lower left corner of the chalkboard. On the lower right corner is the equation for weight, which is weight equals mass times gravity. It is important to note that weight and mass are not interchangeable terms. To calculate force according to Newton's second law, it is a three-step process. I will demonstrate using the example problem on the top of the chalkboard. The first step is to convert our known values to usable values for our calculation. The knots will be converted to meters per second, and the weight must be converted to kilograms using the conversion formulas on the board. For step 2, we will calculate our acceleration using our known values. V and t1 are 0 since they represent the starting time and acceleration, which both equal 0. T2 represents the 10 seconds, and V2 is our speed of 51.5 meters per second, converted from knots. In step 3, we will solve the equation using our known values by multiplying our mass and acceleration, which would equal 5,780.62 newtons of force. This brings us to Newton's third and final law of motion. When two objects interact, they apply forces to each other of equal magnitude in opposite directions. Some notable examples are when two cars crash or when a rocket takes off. I hope this video was informative for you. I really enjoyed making it. If you enjoyed it, please like, subscribe, and comment on what topic you would like to learn about next. Have a great day, and I will see you in the next video.